children, the third method by which square root can be found out is called the division method or by long division method. When you observe the pattern of finding square root by repeated subtraction and by prime factorization, when the numbers are becoming large, each method is getting lengthier. Let's proceed with division method, and because division method is useful when the numbers are large. The first question is find the square root of 529. In this method, the first step is to arrange 529 like you are arranging for a division problem as a dividend, and the grouping starts from the units place. That means ones, tens, hundreds, thousand, 10,000. This is the place value chart, and you will group the numbers in pairs whenever you get a perfect square number for finding square root. So here 29 will be grouped together as the digits are 9 and 2 in the ones and tens column. Hundreds column, since there is only one digit, let it be alone as grouping. Now, as I told you here, 20 square is 400 and 30 square is 900, which shows that 529 is a number between 400 and 900. Therefore, the square root of 529 will be an answer between 20 and 30. So the first step is the first perfect square close to the digit 5. Which is the perfect square number close to 5 is 2 into 2 is equal to 4. So you can write here 2, here 2, 2 2s are 4, and the normal subtraction of 5 minus 4, 1. You see the digits under the same bar will be written down, that is the number is 129. And now the next step is always the double of this number. That means if you have 2 here, double. The word double is the number to be multiplied by 2 always into 2. So that means what is 2 into 2 is 4. And now you have to get a digit in the units place in such a way that when you multiply that number, it should be the same 129 as all the digits have come to the dividends position. And now here also you can use a bit of easy method as if the last digit is 9, you know the table is either 3 3s are 9 or 7 7s are 49. We learned the property. So the digit here can be either 43 into 3 or 47 into 7. You need not look into all the digits. Here 3 3s are 9, 4 3s are 12. That means the digit here should be 3. Here also 3, the 129, and the subtraction answer is 0. Therefore, the square root of 529 is 23. As I told you, it lies between 20 and 30. So the answer is 23. That means your calculation is correct. The second example is square root of 4096. You can have an idea in your mind. 50 square is 2500. 60 square will be 3600 and 70 square will be 4900. That means 4096 is a number between 3600 and 4900. Therefore, the square root answer will be a number between 60 and 70. The grouping as from the units place ones and tens unit, then hundreds and thousands place. The method as the first step is the perfect square close to 40 is 6 sixes are 36. 6 sixes are 36 and you will subtract. 40 minus 36 is 4, the two digits, and the number is 496. The next step is always find the double. What is the double of 6? It is 12. Again, you can check what are the numbers possible for the number 6 in the unit place is either 4 fours are 16 or 6 sixes are 36. 1 to get, you can very well clearly understand that 6 will not be a number. 124 into 4, 4 fours are 16, 9, 496. 496, the subtraction answer is 0. Therefore, square root of 4096 is equal to 64. This way, if you multiply or if you guess what is the digit or what is the possible digit here in this place, you can complete your problems very fast. The same method can be followed if the number of digits are 1, 2, 3, 4, 5. It's a 5-digit number. It is a 6-digit number and so on. Let me explain a few bigger numbers. Your textbook has only 4-digit numbers, but still the method remains same for 5-digit or 6-digit. The arrangement as 15,129. The grouping as ones and tens, hundreds and thousands, and the last one. The perfect square close to 1 is 1 ones are 1, subtraction 0. You will bring 51 as the dividend here. The next step is always the double of the quotient here, that is into 2. What is 1 into 2 is 2. Again, here still 2 more digits have to come down, so this is not the final step. You can check what is the digit which will give you somewhere close to 51. So you can check with 22 into 2. 2 2s are 4, 2 2s are 4. Check with 23 into 3. 3 3s are 9, 2 3s are 6. 69 is a bigger number, so we have to opt for 44. That is 2 here, and the same you will replace here also. And the answer is 44, subtraction, and 11 minus 4 is 7. Now the last 2 digits, so the number is 729. The next step is the whole of 12 will be multiplied with 2. What is 12 into 2 is 24. Provide a gap here so that if you multiply with the same digits, the answer is coming to 729 because the last 2 digits have already been brought down. Now you can go for the easy step, whether it can be 3 3s are 9 or 7 7s are 49. From 2 to get 7, it's a very small number which shows that The multiplication is only with 3. 243 into 3. 3 3s are 9. 4 3s are 12. 7 29. That is 3 here, 3 here, and the subtraction, and the answer became 0. That means square root of 15,129 is 123. Next example of 258064. That is, it is 2,58,064. The grouping from the right 64, 80, 25. And now the perfect square close to 25 is 5 5s are 25. 5 into 5, 25, 0. And now 80, and you will double 5 into 2 as 10, and you can see here, if you insert the digit from the minimum as 101, you can see it is bigger than 80. So what is the digit possible there? It is only 0 or 0. It becomes again a 0, 0, subtract 80, and then 64 will be brought down. So this step, please be careful. When you have a number smaller in the dividends place, even the minimum number of 1, if it is a bigger number, you just insert a 0. Any number multiplied by 0 is 0. You can subtract with 0, and then the next two digits will take the place, and the number becomes 8,064. The next step is double of 50. Double of 50 into 2 as 100. The rule of 4. Either it should be 8 into 8, 64, or 2 into 2, 4. Now you can have a look on 1 and 8. That is, preferably it will be the digit 8. Check with 8. 1008 into 8. 8 8s are 64. 6 0 8 0 6 4. That means 8 8 8064. The subtraction became 0. That is square root of 2,58,064 is equal to 508. Almost all the patterns I have worked out with. Please do exercise questions from your text. The next topic is to find the square root of decimal numbers which are perfect squares. What are decimal numbers? Decimals are fractions whose denominator is multiples of 10. When you look into the place value chart, the number system started with ones, tens, 100, 1000 and so on, which made the whole number part, and then the fraction with the denominator 10, 100 formed the decimal fractions, or the decimal part is introduced. Thus, a decimal number of 17.64 has whole number part of 17 and decimal part as 64, and you are reading the decimal as 17.64. After decimals, you will read the digits in a single notation. Now, when you check the square root of decimal numbers by long division, the only difference is for the grouping of the digits. If you are supposed to find the square root of 17.64, the decimal has to be considered. That is, you are separating it as whole number part and decimal part. The whole number part you will group as you were grouping for the other whole numbers, that is grouping of ones and tens. And in a decimal part, the first place starts with 1 by 10, 1 by 100. So the decimal group will be starting from the 10th place and 100th place. Similarly, if you have to find out the square root of 156.25, 156 is the whole number part, 0.25 is the decimal part. The whole number part will be grouped as 56 and 1 and the decimal part 25. So the grouping only is different, the remaining steps are same as in the long division method of whole numbers. Now close to 17 is the perfect square number. 4 4s are 16. Subtraction of 1. The decimal will be placed over the top for the quotient column also. 64. Double of 4 is 8. To check 4, it can be either 2 2s are 4 or 8 8s are 64. Since the number 8 here and 16 here, it is 82 into 2. 164, 0. No need of placing the decimals in the workout part. Only the decimal has to be retained in the answer section. Or square root of 17.64 is the same as 4.2, and you can check your answer as 4 4s are 16. That means 17 is close to the perfect square number 16, and so your answer is correct. Next is square root of 12.25. Square root of 12.25. 12.25. 12 as the whole number part, 25 as the decimal part. 12 in this grouping and 25 from the 1 by 10 or 1 by 100, that is 10th and 100th position. Next, the perfect square close to 12 is 3. 3s are 9. Subtraction answer is 3. Double of 3 into 2 is 6. And 25, 325. The chance of getting 5 is 5 5s are 25. So 5, 25, 6 5s are 30, 325. You can place the decimal. Don't forget to place the decimal. Therefore, square root of 12.25 is 3.5. Similarly, 2.56. 2.56. Whole number part, decimal part. Same way, the close number is 1. 1s are 1. Double of 1 into 2 is 2. 56. Decimal is placed. To get 6, either 4 4s are 16 or 6 6s are 36. Check with 24 into 4. 4 2s are 8. 96. No, it is 26 into 6. 36 3. 15, or it is 6 into 6, 156, or it is square root of 2.56 is 1.6. Let me work out a number with a more number of digits in the decimal part. The method remains the same. 62.7264. Find the square root of. The grouping is from the ones and tens place, and here, here and here. Now the perfect square close to 62 is 7 7s are 49, 8 8s are 64. So it becomes only 7 7s are 49. You can subtract as 12 minus 9 is 3, 5 minus 4 is 1. Next, the double of 7, that is into 2 is 14, and 2 digits of 72 is coming down, that is 1372. 2 more digits have to come down, so you have to find a digit in this place so that the answer should be close to 1372. 1 to get 13, it's going as 13 times, so let's check with 9 times. 149 into 9. 9 nines are 81, 9 fours are 36 plus 8, 44. 9 plus 4 is 13. 1341. 1341 normal subtraction. 2 minus 1, 7 minus 4, 3, 64. Again, the next step goes as double of 7.9. It's a double of 7.9 into 2. That is 7.9 into 2 is 9 twos are 18, 158, or double of 79. The decimal place no need to be considered. 158, and the chance of getting 4 in the units places with 2 into 2, and in the thousands place as 3. So 1582 into 2, 2 twos are 4. 16, 11, 3164. 3164. Therefore, the square root of 62.7264 is the same as 7.92. So, only the grouping in the whole number part from ones and tens place, then goes to hundreds and thousands and so on, whereas the grouping from the decimal part is from 10th, 100th, then 1000th, 10,000th and so on, because decimal part started with the 10th place or 1 by 10 position. The next type of question by long division is find the least number to be subtracted from a given number to make it a perfect square, and find the least number to be added to the given number to make it as a perfect square. If you recollect the topic, that is the square root done by prime factorization, there the problems were find the least number to be multiplied and divided with a given number to make it as a perfect square, and the multiplication and division part we were doing with prime factorization, whereas with the long division method, what is the number to be subtracted and what is the number to be added. Let's do the first type. What is the number to be subtracted from 402? That is, 402 is not a perfect square. Now, which is the smallest number that should be subtracted from 402 so that the resulting number is a perfect square? As the long division, you can work out 402 from the units and tens place, the grouping. Perfect square close to 2 is 2 twos are 4, 0, and double of 2 is 4, and 0, 2, that's, as I told you, it is a 0, 0, 0, and the subtraction answer is 2. That means 402 has to be subtracted by this remaining number here. 402 minus 2 is equal to 400, and 400 is a perfect square number. So you can write, therefore 2 has to be subtracted from 402 so that the resulting number is a perfect square. Is a perfect square, and the square root of 400 is 20. Even by long division, you can find out that. Let's go with the next one, 1989. 1989, the grouping 4 fours are 16. 389. Double of 4 into 2. That means it is 8. Since the number is not a perfect square number, you need not check with 83 into 3 or 87 into 7. It should be a number close to 389. That is 8 fours are 32. So you can check with 84 into 4, 336. 336, 9 minus 6 is 3, 53. You got a remainder 53, that is 1989 minus 53 is 1936. Let's see whether 1936 is a perfect square. 1936, 4 fours are 16. 336, double of 4 is 8, and we already calculated 84 into 4, 4 fours are 16, 36. So that means in this type of problems, the remainder what you are getting here should be subtracted from the given number to make it as a perfect square. That is 53 has to be subtracted from 1989 so that the resulting number 1936 is a perfect square number. The next pattern is find the least number to be added to get a perfect square. The question is find the least number added to 525 to make it as a perfect square means 525 is not a perfect square. What is the minimum number to be added to it? The initial steps are the same as here, how you have done for the subtraction. The closed perfect square is 2 2s are 4, 125. The double of 2 is 4. When the last two digits are here and the number is 125, for the number to be subtracted, what we did was, we found a number close to 389 but smaller than 389. That is the difference here. We should get a number which is just bigger than 125. So, 43 into 3 is 129. 42 into 2 is 84. The smaller number is 84. For subtraction, we could have taken 84. But for addition, the next bigger number you must take. And instead of minus 4, that number 129 minus 125, that is 4. Therefore, the number 4 has to be added. If you see, 525 plus 4 is 529 and square root of 529 is 23 and 529 is a number bigger than 525 also. So, the step, the place where you get the difference in the step is when the last two digits or the last multiplication, instead of a smaller number close to it, we get a bigger number and then the subtraction as the difference as normal and that number has to be added. Let's go with one or two more examples. Two more examples for this particular question. Find the least number to be added with the given number to get a perfect square. 1750 is not a perfect square. 1750. 4 fours are 16. 17 minus 16 is 150. The step remains the same as multiply. Now 81 into 1 is 81. That's a smaller number. And 82 into 2 is 164. The bigger number we have to opt for. And the subtraction is 164 minus 150 is 14. Therefore, 14 has to be added to 1750 to make it a perfect square. And the number is 1750 plus 14, 1764. And square root of 1764 is 42. We have worked out earlier. The next one, 1825. What is the least number to be added? 4 4s are 16. 225. Double of 4 is 8. To get 20 is 8 3s are 24 or 8 2s are 82 into 2, 164, smaller number. 83 into 3, 3 3s are 9, 249. The next bigger number. So you can take it as 249. The subtraction is 249 minus 225. That is 24 has to be added. 24 has to be added to 1825. 1849. Let's see what is the square root. 1849. 4 4s are 16. 249. Double of 4 is 8. 83 into 3 is 249. Or the square root of 1000. Square root of 1849 is 43. I hope the method is clear. By prime factorization, you can understand what are the prime numbers to be multiplied or divided with, or what is the number to be multiplied or divided to make the given number a perfect square. And by long division, you can understand what is the minimum number to be added or subtracted to make a number a perfect square number.